Hello, geometry students. We're going to continue with the problems we have here, which is we want to find the perimeter and area of the regular polygon and round the answer to the nearest tenth if necessary at all. Okay, so remember that our strategy is to cut up or split these this shape here into smaller triangles. So I have a hexagon, and I'm going to split it up here into 6 smaller triangles. And we know that all of these radii are going to be 8 all the way around here. And if we could figure out one side length, we could figure out what this is, then we can just add them all up and get the perimeter. So we're going to do 2 parts. You're going to do perimeter, and then we're going to do area. Okay. Well, let me draw a bigger version of this thing. Okay. Now, let's think about this for a minute. The central angle is going to be 360 divided by 6, or 60 degrees. So this is 60 degrees. Okay. Now, these 2 lengths here happen to be congruent because they're radii. So that means these 2 angles down here have to also be congruent. And for this special case, for these 2 to be congruent, they both have to be 60 degrees as well. So this is very convenient. And what we have here is an equilateral triangle. Because if this is 60 degrees and both of these are congruent, then they also have to be 60 degrees. And you have an equilateral triangle. So if this radius here is 8, then this is also 8, and this is also 8, all the way around. So the perimeter for this question is pretty straightforward. The perimeter then is 8 plus 8 plus 8 plus 8 plus 8 plus 8, or 8 times 6, which is 48. Okay, so the perimeter is pretty straightforward to find. Now, where we apply the strategy is to find the area. So we want to find the area of one of these triangles, and then we can just multiply it by 6. So the area of these triangles, well, I'm just going to draw one triangle in here. This is 8, this is 8, this is 8 as well. Whoops. And if we draw one of these things in here, this is called the altitude. We know that this is 60 degrees, and this line here splits the triangle in half, so we have something that's 30 degrees here. Okay. So if you just look at the shaded triangle, what we have here is a 30, 60, 90 triangle. So I'll draw the small version out here. You have a 30, 60, 90 triangle. And if this is 8, then this length here must be 4, and this length here must be 4 root 3. Okay, using 30, 60, 90 theorem. Okay. So what that tells us then, the area of one of these triangles, and when I say one triangle, I mean like the big triangle here, is equal to 1/2 the base, which is 8, times the height, which is 4 root 3. Okay. And then that means the area of the hexagon is equal to 6 times 1/2 times 8 times 4 root 3. The reason being, in a hexagon, there's 6 of these big triangles here. Let me show you this picture again. All right, so when you have a hexagon, you're able to split this up into 6 of them. So you want to multiply this by 6. So all of this comes out to 2496 root 3. Okay, 1/2 times 8 is 4. So this is 4 times 4 times 6. That's 96 root 3. So that's the area. Okay, so I want to make a few points here. You see how up here we have an equilateral triangle, and you want to think, great, this is true for everything, But when we have this equilateral triangle, it only is that way for a hexagon. So this triangle is equilateral only for hexagons. Okay, it's only for hexagons. For any other shapes, it's going to take us a little bit more work. Okay, so I'm going to stop this video here, and I'm going to start another one where we work on the pentagon.